Graph y is equal to 0.5 sine 2x plus pi by 2 and find amplitude, phase and period. So let's plot this graph y is equal to 0.5 sine 2x plus pi by 2 with different values of x ranging from say minus 2 pi to 2 pi or something like that. You just need to put x as different values like minus pi by 4, 0, pi by 4, pi by 2 and so on. So if you plot that, let's plot y is equal to 0.5 sine 2x first. Let's forget about the pi by 2 there. If you plot y equal to, let's take a different color. Let's plot y equal to 0.5 sine 2x. Okay, so sine 2x starts from origin, as we know. It's steeper, comes down, again steeper, comes down. Should be a little smooth and symmetric. And so on. And same thing in the sorry for the awkward drawing, but it should be symmetrical. So this would be 0, this would be pi by 4 for sine 2x, this will be pi by 2, this will be 3 pi by 4, this will be pi, and same thing, this will be minus pi by 4, minus pi by 2 and so on. And if you check the max value of whole 0.5 sine 2x function would be, this would be 0.5, unlike 1 for y is equal to sine x. Since we have 0.5 sine x, the max would be 0.5 and minimum will be minus 0.5. That is the difference you'll have here for y is equal to sine 2x. Now if you plot the same curve for sine 0.5 sine 2x plus pi by 2, let's take a different color, and if you plot on the same curve and use the same values of x, probably the minus pi by 4, pi by 4, and plot it on the same plot here, and then let's assume that the sine 2x actually starts from 0. So let's remove this part of the function here, and let's start it from only 0. Let's think it starts from only 0. So let's remove this part of the curve. So this is a 0.5 sine 2x from 0 to say pi here. Now let's plot 0.5 sine 2x plus pi by 2. So when x equal to 0, this is actually sine pi by 2, and sine pi by 2 is 1. So at 0 it starts, or 1 times 0.5 is 0.5. So it starts at 0.5 and then tries to copy the curve or go parallel to the curve, and then goes here. So basically there's a lag between sine 2x and sine 2x plus pi by 2. Okay, so this is the plot for sine 2x plus pi by 2. What is an amplitude? Amplitude is actually the maximum distance the curve goes in y-axis. So here to here, this is called amplitude, or A. So the amplitude is actually this distance from here to here, or from here to here, the same distance. That is called the amplitude. Phase is the angle here at which it starts at 0. Say normally the sine 2x starts at 0, but then sine 2x plus pi by 2 starts at 0.5, or for sine 2x plus pi, there is no 0.5, it starts at 1. That means it already had some value to it, and that is either the phase lag, something like delay or leading or lagging, that is pi by 2 degrees. So that is the phase, this number here. Period, if you see clearly, the period of sine 2x, which is a blue curve, is same as the period for sine 2x plus pi by 2. So let's see, the period for sine 2x is from here to here, So it's repeating from here to here, which is 0 to. So there's a typo in here. So the pi by 4 should be here, and pi by 2 should be here, and 3 pi by 4 is here. This should be pi. So let's fix that. This should be pi. This is pi by 2. Should be pi. Let's write it down again. So this is pi by 4, and this is pi by 2. So this should be pi by 2. This should be pi, and this should be 2 pi here, right? So now the period for sine 2x is from here to here, which is 0 to pi. It's pi radians. Similarly, the period for the red plot, which is sine 2x plus pi by 2, is from here till here, the max, right? The max of 2 points, or you can say from here, it goes from here to here. That is again pi. It's pi to 3 pi by 4. So it's pi. So which means the period for sine 2x and sine 2x plus pi by 2 is the same. As a matter of fact, the period for sine x and sine x plus theta should be the same. It's just that there is a delay or lag or lead on the curve, but the actual periodicity is the same because they're parallel, right? Similarly, the sine 2x plus pi by 2 and sine 2x has the same period. So the period for sine 2x plus pi by 2 is still pi.